Hi, it's Charlie Zeese from the Pyramid Science Foundation. Today's video is going to be about universal phi scaling in birds and water animals. We've been doing a bunch of videos recently demonstrating the existence of universal phi scaling in high technology, but I wanted to go back and look at uh, probably the origins. The scientific method, observation of nature is key and really should be the first step in any scientific study. But we're going to see that this geometry uh, exists in the birds and in the water animals as well. And we've gone over why that is the case. Universal phi scaling seems or does reduce the friction and drag associated with movement in any sort of fluid in fluid dynamics. So it doesn't really matter whether it's in the air or in the water, but the use of universal phi scaling helps these animals to move through their respective medium of air and water more rapidly and with less effort. So let's get started. So here's some pictures from our thumbnail. On the left, we have some examples of trout. As you can see, we find this not only on the bottom of the fish, we also see it on the top of the fish. We've got other pictures of fish from the view of the top, and you'll see that both in the horizontal and the vertical plane for both birds and water animals, we're going to see that this geometry exists, and that makes sense because if you want to reduce your friction and the drag so that you can fly or swim more easily, you're going to want to see this scaling geometry in all dimensions. So on the left, again, we have the trout, and on the right, we have the Peregrine falcon, which is the fastest diving bird on the planet. So we're going to start with the water animals. Here's an example. This is an orca whale, and we can see this 27.309 degree geometry. And to remember universal phi scaling, there's two fundamental dimensions that we'll find. One is the apex angle of 27.309, and the other, if you're looking at it as a triangle, is the base angle of 76.345 degrees. So we're going to see both of those in examples today. But here's an orca whale, again, showing this geometry in the back end of the animal. Now here's a humpback whale, and here's an example where we're going to see it both in the horizontal and the vertical plane. We see the humpback whale here in a vertical image, and we find this geometry in the front of the whale. And once again, we have on the right-hand side, we have a view from the top of the whale, and we see this geometry there as well. And here's the great white shark. We'll see that again. On the side view, we see this geometry in the back of the shark. And then I found this under view of the front of the shark, and you can see the 76.345 degree angle there that shows up as well. So we're seeing it in both the horizontal and the vertical planes with the great white shark. Here's a Greenland shark, and I don't have a side view of this one, but you will see once again in the rear of these fish, this seems to show up almost universally. And again, here's a top view of a blue dolphin. We see it in both the back of the dolphin as well as in the front. And here's an Atlantic humpback dolphin. We once again see it. You see, this is just so universal, so fundamental to the geometry of these fish and sea animals. Now here we're getting into some other types of animals. Here's a crocodile. We can see both from the side view and the vertical plane, the 27.309 geometry, and then over on the left side, we see both from the top and the bottom the 76,345. We could have measured it from the top as well, but these are all associated with the very same geometric principles. And the alligator as well. We see it in the front of the alligator as well as from the bottom side. We see the same geometry as well. So both the crocodile and the alligator share very, very similar geometries. Now we're going to be getting into some of the really fast swimming sea creatures. Here's a barracuda that demonstrates the geometry in the front of its anatomy. And here's a bonita. And we see once again the 27,309 both in the front and in the back of this fish as well. And here's a tuna where we see it in the front, or excuse me, in the rear of the fish. Mackerel, I got pictures here where it shows up in both the front and the back of the fish. It's a very fast swimming fish. And then here's some larger fish, again amongst the fastest in the oceans. The swordfish has this geometry in both the front and the back of the fish, as does the marlin. Here I've got it in one picture, both the front and the back. And here's a sailfish, another one of the fastest fishes in the ocean. And it demonstrates that geometry. I really couldn't find a good rear photo of a sailfish out on the internet, so I couldn't really measure that. And then finally, the trout that we showed on the cover page. Again, we see it both in the front and in the rear geometry, both top and bottom. And then here we have as well a front view, which gives us a side angle, and we see that geometry exists there as well. So this, the trout was actually the fish that Victor Schauberger analyzed in great detail, and he developed his water technologies, including some free energy devices based upon water, using this very geometry of universal Phi scaling. So now we're going to move on into birds, and we're going to see several pictures here of the peregrine falcon. This is the fastest diving bird that exists on planet Earth. And we see again the very streamlined body of the falcon in its diving position, and we see this aerodynamic design with the 27,309 geometry at the back of the bird. And we also seem to see this at the tip of the wings of the peregrine as it's flying. So another example of that geometry. Here we're seeing the falcon in flight. We see the 76.345 geometry of the wingspan, which I'm sure is aerodynamically important, and also in the rear of the body of the falcon as well. So it's no surprise we're finding this in numerous angles and components of the anatomy of the peregrine. And here's two more demonstrating this geometry in the front and also in the wings again of the peregrine. Now here's three examples of an osprey diving. And I wanted to go ahead and take all three of them because they demonstrate that these photographs aren't flukes. These are different observations, but every single one of these has this 76,345 geometry. And we've seen this in the tails of the aircraft, but I have an example of it here in an upcoming slide, how similar all of this looks. This is, again, one of the fastest birds in the sky, the white-throated needletail. And we see this geometry, universal Phi scaling in both the front and the back half of the needletail. And here's another fast bird called the Eurasian hobby. And we see it again in the rear of that bird as well. Here's a pelican, demonstrating just as the osprey did, as it dives, it pulls the wings back at a particular geometric angle, which is indicative of universal Phi scaling. And here's another fast flying goose. This is called the Spur-Winged goose. And here I threw in, just to let everybody see, what the back end of a typical jet airliner looks like. And it almost looks like they just copied the back end of these birds to develop the model for jet aircraft. I know they did it with wind tunnels, but I wanted you to show you how very precise the results that we find through wind tunnel testing, which is how these jets were developed, how it parallels nature itself. So not a surprise here. Both are in nature. This was done through I say a higher intelligence that crafted this geometric design for the birds. But here we have as well the jet airplane, which used wind tunnels, and also did not use sacred geometric principles as well. Here's the red-breasted Merganser. Again, you'll see this geometry in the back of the bird. The gray-headed Albatross as well has this geometry. You see how close it looks to the jet aircraft. Again, visualize that. And here's the Canvasback goose. You see it both in the front and the rear, very aerodynamically designed. So as you can see, there is multiple examples, especially with the fast swimming sea creatures as well as the fast flying birds, that this sacred geometry of universal Phi scaling is everywhere. And for those of you who are new, you know that our pyramids use this exact geometry to order, provide for coherent energy fields for health and for well-being for our customers. And it's all due to sacred geometric principles. Hope this was of interest to you. I thank you for watching, and you have a great day.